Welcome guys. So let's solve in this 1976 number of ways to arrive at destinations. Okay, so this problem is very easy. You got some graph and you initialize at 0, and there are total -1 vertices. And the problem is that given all the give the number of all the shortest paths from 0 to 0 to n-1. Okay. And so you start from 0 and go n-1. So this is the single source shortest path. And very good is that this is time, right? So there's no these are all the graph are non-negative. So simple graph. So you can use the diagram. Okay. So there's a same problem that similar problem, right? But the usual, so this is the usual diagram. Okay, so idea, let me quickly review. So the diagram idea is that you first have some physicist, and you have some weight, and you pass. So this is if you want to know the shortest path. If you don't want to know, then you can delete every path. Okay, there's a queue and the weights, and so initialize the source set to be 0, and then you push, you create a heap. Okay, so I create a heap PQ and push, and then you take the smaller one and put into physicist, and if not yet physicist, you try to do the so-called relaxation. Okay, so this is the usual diagram step. Okay, and if f, which is the distance plus the weight less than the v, then you just push back. You just push. Okay, and the final you can return the path and weights. So weights will be a matrices, which is a single source. Okay, so I will put this into my I will put this below if you want to copy this code. Okay. But basically, all you need to do usually is to create a graph, which is for each vertices you given a list, which each element is a tuple, vertices and weights, and you can use the usual diagram. Okay, but the problem in this one is that we need to count, right? So we need to do something non-trivial. So first part still very easy, just create a graph. Okay, so here's a create a graph. And for this one, I initialize a so-called count. So this count is that given vertices, and I need to return the number of the shortest path. Okay, so count for source is 1, right? Because 0 go to 0 must be 1. Okay, and the difference is that if we find a new weight, so we find a new smaller path, then count v equals count u. Otherwise, that we find another directions, which count v should add count u. So this is the only difference. You just copy the original diagram and then write these two codes. Okay, so write these two parts. And the final return path, weights, and count. So you just call our answer diagram n0g. So n is the number of nodes, 0 is the source, and the final you return counts n-1 modulo this. So this is not important, right? But just module. Okay, so this problem is very simple, that just use a simple diagram, and the only difference is that you mod these two, you add these two conditions. So it's very simple that you can easily solve. Okay, see you guys next videos.